Okay, Assalamualaikum warahmatullahi wabarakatuh and very good evening. Okay, for today's lecture, we are going to cover the topic on hypothesis, and we will try to go through the slides. There are roughly around 38 slides, including the front page. Okay, we have already looked into problem statement, and most likely all of you have already tried to write the problem statement based on your topic. And for today, I'm going to go through with you on how to write the hypothesis. Right. In terms of the content of our lecture tonight, we are going to look into several sub topics which include the learning outcomes, and then we are going to go through the research structure and looking into the definition of hypothesis, and we will look into the nature of hypothesis and followed by the types of hypothesis available and the methods of formulating hypothesis, and finally how to test and typical errors in writing hypothesis. Right, so basically we should be able to go through all of this content in this particular lecture. In terms of the learning outcomes, right, so we at the end of this session you should be able to do mainly all of this, meaning that you are be able to at least get to know what is hypothesis all about, meaning that to define hypothesis, and then you will also be able to identify the process involved before formulating hypothesis. Okay, what are the things that you need to do before you formulate your hypothesis. And basically, you should also be able to explain in terms of the methods to formulate hypothesis, and discuss on how to do the testing as well as finding errors in hypothesis. And finally, the last two is distinguish between the two types of hypothesis. And eventually, right, you also be able to write your own hypothesis. Okay, in terms of the research structure, right, we have already looked into the beginning where we have the K chart, we have the system layers, and then we have the methodology on the result layers, and you also already look into how to write the objective, and we also look into problem statement. But mainly the research structure help us to create research which is quantifiable, right? Meaning that the research that you are doing must be able to be quantified. It also be able to be verifiable, right? It has to be the topic or the research need to be verifiable, and then it is also be able to be defensible. You need to be able to justify, defense in terms of what the research all about. And finally, the typical research, good research can also be replicable, meaning that it can be repeated by other researchers, or you yourself, you want to repeat the test again and again. It is systematic. Okay. And then in terms of the model, okay, we have the elements of research question, where then you be able to develop a theory, you identify the variables, okay, the design parameters. You also include identifying the hypothesis, where it also include the type of hypothesis. You evaluate the results and do critical review. You do analysis on it. In terms of the common sense, why we are talking about research structure here, okay? Of course, you will find your answer in your research in terms of how to do it, or what is the expectation from the research that you are conducted, and then you involved in collecting and analyzing data. What is it means? What it does not means? And then finally, in terms of the structure of research, is also include paper format, where you do introduction, you do methodology, you have your results, and finally your conclusion. I'm just trying to recap of what all research all about. And then the most of the research projects will share the same general structure. I'm trying to share with you the other perspective of looking at research, which could be represented in the shape of an hourglass, the shape of like a glass. Okay, the hourglass notion of research include which you will begin with broad questions. I hope you can still remember the spiral of knowledge. Okay, you then narrow down and you focus in, like you are doing in your K chart. Okay, you operationalize it, you implement the items, you observe the results, and then you then analyze your data, you come to research conclusions, and you go basically generalize back to questions. So the cycle continues from the beginning until the end, and the cycle continues. It's like an hourglass notion of research. Some of the methods that are included for research formulation, okay, where, for example, like where does the problem origination or discovery begin? Okay, how do you get the problem, right? How do you know that there is an issue to be resolved? It can be come from your previous experience, right? You come out or you happen to face certain issues, okay, your own experience, right, or your family experience or your friends experience that happen in front of your eyes, that can become the origination of the problem. Okay, that can also be triggered from interest and maybe potential problem fields. And the research formulation also involve criteria of problems and problem statement, and goals, and also planning. You can also have a research, explore and gather the evidence, generate creative and also logical alternative solution. All of these basically will lead you to making educated guess. What meaning that you are trying to assume what's going to happen, right? That is what we call the hypothesis, right? Now, we would like to go into more academic definition in terms of what is hypothesis, okay? So let me try to get my pen working, okay? Okay, hypothesis, according to Rogers in 1966, quite old definition, but you can simply Google and try to find other definition of hypothesis, where hypotheses are single tentative guesses. The keyword here is what? Single tentative guesses. Maybe it can be good hunches, right? Assumption, assume for use in devising theory or planning experiments intended to be given a direct experimental test where possible. All right. So this is just one expression of definition by Rogers in 1966. Let us look at another one by Kellinger, 1956, which 10 years older than the previous one. A hypothesis is a conjectural statement. Okay, it is a conjectural statement of the relation between your two or more variables. It can be you have two or more design parameters, okay, that can be influencing or affecting your performance parameters. Okay, so It is a statement that what's going to happen. eh? So let us see another one in term of this is coming from Creswell, 1994. Hypothesis is it is called a formal statement that presents the expected relationship between independent variable and dependent variable, or in other words, your design parameters and your performance parameters. Okay, so another definition here by Sarantakos in 1991. Okay, a hypothesis can also be defined as a tentative explanation of the research problem. So you have your problem statement, right? And it is trying to summarize what's going to happen, the assumption, your expected result, a possible outcome. It mentioned here a possible outcome of the research or an educated guess about the research outcome. So basically, it's just the intended result, the intended results that you would like to come out from the research. Okay, so that are we can continue look at different definition, but eventually what is important on how to create a hypothesis. Okay, in terms of the nature of hypothesis, a hypothesis is a clear statement, right? A clear statement of what is intended to be investigated. Like I said just now, from the definition, you would like to see the effect of design parameters on the performance parameters. And it should be specified before research is conducted. Okay, some people say that, oh, why we need to do hypothesis? But eventually, when you write your dissertation at the end of the course, you are required to put down your hypothesis, right? Even though you have your problem statement, you have your good objective, and then your scope of study, you have a list of research question, but the examiner will ask you, what is your hypothesis? Whether you have proven your hypothesis, okay? By having said that, the nature of hypothesis will allows you to identify the research objectives. From the hypothesis, you can also identify the research objective. At the same time, from the research objective, you can also generate the hypothesis. It also identify the key abstract concepts involved in the research. And it also identify its relationship to both the problem statement and the literature review. Okay, so the hypothesis basically will link the information from your literature review. You have the gap in the knowledge, and from there you can then put up the problem statement, and from the problem statement it can also allows you to harvest or put out the assumption what's going to happen. A problem cannot be scientifically solved unless it is reduced to hypothesis form. So you already have your problem statement. Now, how are you going to reduce it to hypothesis form, right? Of course, it mentioned here, it cannot be scientifically solved unless it is reduced to hypothesis form. So it is a powerful tool of advancement of knowledge, consistent with existing knowledge and conducive to further inquiries. So hypothesis, it can be tested. This is the characteristic, okay, of hypothesis. It is also not moral or ethical questions, right? Of course, it's not a moral, it's not also ethical question, neither too specific or nor too general, right? And it is a prediction of consequences, right? And it is considered valuable even if proven false. So these are the what we call it as the characteristic. characteristics of hypothesis or the nature of hypothesis. If you do not have these elements, meaning that it is not a hypothesis. Okay, if it is about moral or ethical question, it is not a hypothesis. So let us see later on. There are a few examples that we can share to see what is hypothesis and what is not. One example being given here, okay, imagine that you are a nutritionist. You are working in the zoo, and one of your responsibilities is to develop a menu plan for the group of monkeys. Somehow, this example given monkeys as then staying in the zoo. So, in order to get all the vitamins, the monkey need to be given fresh leaves as part of their diet. Okay, choices you consider include leaves of the following species. You have leaf species A, B, C, D, and E. And you know that the wild monkey eat mainly bee leaf, right? Because you already know from the literature or from your own experience, but you suspect that this could be because they are safe whilst feeding in bee trees, whereas eating any other species would make them vulnerable to predator. I mean, they would be in danger. Okay, and then you design an experiment to find out which type of leaf the monkeys like best. You want to know which one actually, A, B, C, D, or E, that the monkeys like best. Okay, and then what you do is basically you offer the monkeys all 5 types of leaves in equal quantities, right? You put it in the container, and then you give the monkey equal quantities of each leaves, A, B, C, D, and E, and observe what they eat. Okay, that is the experiment. Right. So there are many different experimental hypotheses you could formulate for the monkey study. So just for example here, when offered all 5 types of leaves, the monkeys will preferentially feed on bee leaves. Okay, from this is the hypothesis. So from here, we can easily see that, right? So the you can easily see that we are assuming or we are expecting the monkey will eat the bee leaves, not A, C, D, and E. Okay, this is before the experiment begins. It is you are making an hypothesis. So let us see in terms of the characteristic. This statement satisfies both criteria for the experimental hypothesis. It is a prediction because you are assuming, you are guessing what's going to happen. It predicts the anticipated outcome of the experiment, right? And then testable. So you can test because from the result, bee leaves finish, right? Compared to other leaves. Once you have collected and evaluated your data, or observations of what the monkeys eat when all 5 types of leaves are offered, you know whether they ate more bee leaves than the other type. Okay. An example of incorrect hypothesis, it would include, for example here, when offered all 5 types of leaves, the monkeys will preferentially eat the type they like best. Okay, what's wrong with this? Okay, so this statement certainly sounds predictive. Okay, it is sound that what's going to happen, but it does not satisfy the second criterion. Okay, there is no way you can test whether it is true once you have the results of your study. Okay, your data will show you whether the monkeys preferred one type of leaf, but not why they prefer it. Okay, in other words, they like it best. So this is in fact a statement of assumption, not a hypothesis. So incorrect hypothesis would also include when offered all 5 types of leaves, the monkeys will preferentially eat bee leaves because they can eat this safely in their natural habitat. So how do you know? So this statement is also problematic, okay? Because its second part, they can eat this safely in their natural habitat, which is, you don't know, also fails to certify the criterion of testability. So this is not cannot be tested. You can tell whether the monkeys preferentially eat bee leaves, but the results of this experiment cannot tell you why. Right? So that's a good example. And another incorrect hypothesis would include when offered all 5 types of leaves, which type of leaves will the monkey eat preferentially? So there is a question mark there. So this is a question. A question cannot be a hypothesis. And questions fail to satisfy criterion number 1. They are not predictive statement. It is a question mark. A question is not a hypothesis. All right. Now let us look into the types of hypothesis. We have 2 types of hypothesis. The first one is null hypothesis, and the second one is alternative hypothesis. And null hypothesis is normally designated by H naught or Hn, and alternative hypothesis designated by H1 or HA. Okay, so in our case, we will use H naught and H1. So let us look at one by one. What is null hypothesis? Okay, a null hypothesis represents a theory that has been put forward either because it is believed to be true or because it is used or it is to be used as a basis for argument but has not been proved. Okay? So it has serious outcome if incorrect decision is made. So null hypothesis. If it is wrong, meaning that you will have a serious outcome. Maybe the whole thing will collapse in terms of the research. Whereas the alternative hypothesis, in terms of definition, is a statement of what hypothesis test is set up to establish. It is the opposite of the null hypothesis. Okay? And it can only be reached if the first hypothesis, which is the null hypothesis, is rejected. It is not true. If null hypothesis is not true, then we can have the alternative hypothesis or H1. And frequently, alternative is actual desired conclusion of the researcher. So imagine you have 2 hypotheses, right? The first one, for example, like the case of the leaves with the monkey just now, okay? You assume your first hypothesis is that bee leaves is the most likely, or the monkey like the most, and then the alternative hypothesis, maybe you have leaf C, so because you don't know which one. So if B is not happening, okay, you may have the other one, maybe C. Okay, there are example here that we can look into. For example, here in a clinical trial of a new drug, okay, the null hypothesis might be that new drug is no better on average than the current drug. Okay, so we would write, okay, H naught or null hypothesis, there is no difference between the 2 drugs on average. That is our hypothesis, null hypothesis. The alternative hypothesis might be that the new drug has a different effect on average compared to that of the current drug. We would write the alternative hypothesis as the two drugs have different effects on average. You can see from the two. Okay, let me just try to use a different color. Okay, right, because it is red here, we use blue. So you can see here, there's the opposite. The first one, the null hypothesis, there's no difference. And the alternative hypothesis is that have different effects. Okay, so because this is the opposite, right? Like the example of the monkey love bee leaves. The null hypothesis is that the monkey love the bee leaf, will eat bee leaf. The null hypothesis is that the alternative hypothesis, it can be the monkey will eat all leaf regardless of the type, right? So it just disrupt the whole thing. It is the opposite. So similarly like this, the null hypothesis, there is no difference between the two drugs on average. But alternative hypothesis, the two drugs have different effects on average. So the new drug is better on average than the current drug. We would write the new drug is better than the current drug on average. Okay, so you can also have another alternative where you can say the new drug is better, is better than the current drug. Okay, the first one is no different, and then the second, the alternative is have different effect, but you don't say that which one is better. And then you can also have another alternative hypothesis that the new drug is better than the current drug, because you don't know which one is which, because you are going to prove it later on in your experiment. We give a special consideration to the null hypothesis. This is due to the fact that null hypothesis relates to the statement being tested, right? Whereas the alternative hypothesis relates to the statement to be accepted if the null hypothesis is rejected, right? You can see that if it is not null hypothesis, it can be the alternative hypothesis 1 or alternative hypothesis 2. And the final conclusion, once the test has been carried out, meaning that you have done your experiment or simulation or from your surveys, so you will get the result. Is it proven? So it always given in terms of the null hypothesis. Okay, we either reject null hypothesis in favor of the alternative, or you do not reject null hypothesis. So we never conclude reject alternative or even accept alternative hypothesis. So you have to read this carefully. So if we conclude do not reject null hypothesis, meaning that you accept the first assumption, this does not necessarily mean that the null hypothesis is true. So it only suggests that there is not sufficient evidence against the null hypothesis in favor of the alternative hypothesis. Okay, rejecting the null hypothesis then suggests that the alternative hypothesis may be true. Okay, if, in other words, if H naught is not true, then H1 may be true. Okay, so if H naught is correct, so you is not, this does not mean that it does not mean that H1 is wrong. Okay, so the first statement is what we meant here. So you cannot assume that okay, you already accept the null hypothesis. It doesn't mean that your alternative hypothesis is wrong. Okay, unless you prove it. Okay, so let us continue. Right? And how to formulate hypothesis? It is important to narrow a question down to one that can be reasonably be studied in the research project. So the formulation of the hypothesis basically varies with the kind of research project conducted, whether it is a qualitative research or methodology, okay, versus the quantitative methodology. Okay, so which one? In terms of formulating hypothesis, it can also be divided into deductive. Right? The first one, okay, you have deductive methods where you do observation, you look at the pattern, you have tentative hypothesis, and it will come out to the theory. Or you can have inductive methods where you start with your theory and you come up with your hypothesis and try to observe and to confirm it, right? So these are ways of formulating hypothesis. Right, let us look at the first one, the qualitative approach. The use of research questions. So from your problem statement, you also already have your research objective. You also have your research questions. The use of research question as opposed to objective or hypothesis is more frequent, meaning that in a qualitative approach, normally we use research question instead of having objective or hypothesis. But anyway, like I mentioned in our previous lecture, that I would like you to, whether you are qualitative approach or quantitative approach, I would like you to have your research questions, and we will also have the hypothesis. In terms of the characteristics, use of words like what or how, specify whether the study discovers or seeks to understand, explores, or describes the experiences, and use of non-directional wording in the question. And these questions describe rather than relate variables or compare groups. So the questions are under continual review, right? So meaning that you can go back to the research question and reiterate or reformulate the question. Okay, reformulation will evolve and change during the duration of the study. And the questions are usually open-ended without reference to the literature or theory, and normally we use a single focus. Okay, that's a characteristic of research question in the qualitative approach. In terms of the rules, okay, rules by cleaning offers 4 rules. There are 4 rules here for a scientific and qualitative process of approaching understanding to reality. Oops, too fast. In terms of rule number 1, it refers to the subject or the researcher. Prior understanding of the phenomenon to be researched should be seen as provisional and should be transcended with the discovery of new information with which they are not consistent. And then rule number 2, it refers to the object of the study. And the object is provisional. It is only fully known after the successful completion of the process of discovery. Okay, and rule number 3, research question also refer to action in relation to the subject of research, hence to data collection. And the object should be approached from all sides, rule of the maximum variation of perspective. And finally, rule number 4, it refers to the evaluation of information gathered, hence to the data analysis and analysis of the data for common elements. So these are rules of qualitative approach. And then in terms of the quantitative approach, okay, in surveys, projects, the use of research question and objective is more frequent, whereas in an experiment, if you are conducting experiment or doing simulation, the use of hypotheses are more frequent. You put up hypothesis. It represent the comparison between variables, relationship between variables, and then you prove the hypothesis through the experiment conducted. And the characteristic basically it is testable proposition to be deduced from the theory, independent and dependent variables, the performance parameters and design parameters to be separated and measured separately, okay, to be either writing questions or objective or hypothesis, but not a combination. Consider the alternative forms for writing and make a choice based on the audience for the research. So it depends. When you write your dissertation later on, we will provide you with the format. Okay, the format basically requires you to write the hypothesis. At the same time, you are also required to write the research questions. Okay, this is just an example from the literature. How is it going to normally being happen? In terms of the generation of research hypothesis, the problem statements become research hypothesis. So from your problem statement, okay, you may want to look at your problem statement, then you can then construct the hypothesis and how is it being operationalized. Okay, so basically the initial ideas, right? So we from your general title, okay, and then you have your specific title, then you probably have your existing research literature and initial observation. You gather all of this information like we have done in our previous lecture, okay, and you come up with your statement of the problem statement. Okay, from the problem statement, you may want to define operational definition of the construct and then finally come out with the research hypothesis, a specific deductive prediction. Some student will ask, how many research hypotheses I have to write? All right. So normally you can either have the elements of the null hypothesis. You may have H naught, and then you may have H1, or you may also have another alternative, H1, another H1, another H1. So normally you will have you can have one, you can have minimum two, right? Or you can have 3, 4, and so on. So, but normally you do not have so many variables over there. Okay. Example here, consider the example of a simple association between two variables. We have y and x, okay? You can also have like a temperature and pressure, for example. So y and x are associated, or there is an association between y and x. Y is related to x, or y is dependent on x. As x increases, y decreases, or increases in values of x appear to affect reduction in values of y. So you can try to find out how y being affected by x, or in vice versa. So the first hypothesis, the first statement just now, it provides a simple statement of association between y and x. Nothing is indicated but the association that will allow the researcher to determine which variable, whether is it y or x, would tend to cause the other variable to change in value. Right? The first hypothesis. The second hypothesis is also a simple statement of association between y and x. But this time, it may infer that values of y are in some way contingent upon the condition of the x variable. So because it's dependent on x. So the third hypothesis is the most specific of the three. Not only does it say that y and x are related, because as you increase y, x will decrease and so on, that y is dependent on x for its value. But it is also reveals something more about the nature of the association between the two variables. So the degree of challenge, now we would like to go in more practical mode to the hypothesis, will depend on the type of problem. It's not as simple as, oh, you have one problem, you can easily state the hypothesis just like that. So it depends on the type of problem and in its importance. It can range from just seeking a good enough solution to a much more rigorous challenge. Okay, so if you look back at your problem statement, from your problem statement, you must then have some indication on what's going to happen. What is your assumption? What is your intended result from the problem, the solution that you think that will happen? Okay, the term challenging may include verification. It has to be justification, refutability, validity, rectification, repeatability, falsification. And there are two possibilities: nothing happened, okay, or something happened, right? And if nothing happened, is null hypothesis, and the alternative hypothesis H1. Okay, hypothesis testing. So once you have written your hypothesis, right, there are 4 steps of trying to test whether the hypothesis is correct or not. Is stating the hypothesis, whether it is null or alternative, and whether it is H naught or H1. Setting the criteria for a decision, you collecting your data and evaluate the null hypothesis. In terms of the errors in hypothesis, 2 types of mistakes are possible while testing the hypothesis. Type number 1 and type number 2. Example, small example. Your actual health. Well, what the doctor says. For example, that the doctor says that you are sick. Doctor confirms it right, meaning that you are sick. Okay, but actually you are well. Okay, the doctor said you are sick. You will get scared for nothing. It is wrong. It is type 1 error. Okay, and if the doctor says that you are well, in the actual facts you are sick, the doctor missed your real illness. It is wrong, meaning that it is type 2 error. Is in actual you are well, you are really not sick. Okay, you are right. I don't know whether you can get this example or not. And then if you look in the type 1 error, the type 1 error occurs when the null hypothesis is wrongly rejected. Okay, so you reject hypothesis, the first null hypothesis is wrongly rejected, you will get type 1 error. And for example, a type 1 error would occur if we concluded that the 2 drugs produce different effects when in fact there was no difference between them. Okay, it's the example of the drugs in the earlier example. Type 2 error. A type 2 error occurs when the null hypothesis H0 is not rejected when it is in fact false. For example, a type 2 error would occur if it were concluded that the two drugs produce the same effect. That is, there is no difference between the 2 drugs on average when in fact they produce different ones. So to generalize, okay, so the truth, whether the null hypothesis or alternative hypothesis is the right decision. Okay, if you reject the null hypothesis, it can be type 1 error, and then the alternative hypothesis is the right decision. Okay, if you don't reject the null hypothesis, it may become the truth is it is the right decision. Basically, it is the type 2 error. A type 1 error is often considered to be more serious, right, and therefore more important to avoid than a type 2 error. So basically, in your it all depends on the problem. Let's say you do experiment, actually you wrongly approach the experiment. You're supposed to get the right answer, okay, but somehow in your experiment you get the opposite, right? So you are oops you are okay. So basically, you are make the wrong assumption. Your results suddenly, your wrong results suddenly support your uh, to reject the null hypothesis, which actually totally wrong. Okay, which is a disaster. In other words, it depends on your results, because the hypothesis, you normally write the hypothesis at the early of the stage of the research, but you can then test the hypothesis in the experiments, in the result that you're going to obtain, and from there, if you do come up with a wrong methodology, you get a wrong result. Eventually, you get a wrong type 1 error, which is a disaster. I can say it is a disaster. So, in summary, research question and hypothesis become signposts for explaining the purpose of the study and guiding the research. Because by having a good research question, it will guide you on what is important to be searched, what is important to be analyzed in the study. And hypothesis is basically a goalpost, where you intend to get the end result. Okay, what is going to happen, okay, at the end of the day. So it's like a signpost. And then a hypothesis is an explanation. Okay, it can be an explanation, it can be a tentative and unsure of itself for specific phenomena about which you have questions. A well-crafted hypothesis very often suggests the best way to perform the research and gives you clues as to your research design, right? So there are cases that students, when they put up a hypothesis and they have their good results, and the conclusion, and suddenly the examiner said, please rewrite your hypothesis to suit to your results. Okay, so it happened. It happened sometimes. So there are different type of hypotheses. We have the deductive type and the inductive type. Depend on how you come up with the hypothesis statement. Research hypothesis can either be non-directional or directional. There exists a hypothesis that is opposite of the positively stated one. So like the null hypothesis. To conclude, it would be fitting to say hypothesis is perhaps the most powerful tool man has invented to achieve dependable knowledge. So basically, if you do it right, you have a good hypothesis, it would be a good tool for you to, as a guide for you to embark on your research journey. Okay, so that would be all for today. Okay. So with that, if there's nothing else, feel free, if you have any other question, you can put in the YouTube comments, or you can put in a private message to me, and we can discuss further. All right. With that, thank you very much. I'll see you guys next week. Okay. Assalamualaikum warahmatullahi wabarakatuh.